Well, hello, everyone. Welcome to this, what promises to be a very interesting session on emerging technologies and how they're shaping water management. Um, we have three excellent panelists who are going to walk us through a variety of different topics under that umbrella and focus on water. Of course, there has been just an explosion of discussion around AI and generative AI and how that's sweeping across and disrupting a variety of different sectors. And I think we're going to both explore that and both potentially temper that enthusiasm and perhaps amplify it. So might have a lively discussion across both of those aspects. I'm Paul Fleming. I'm a advisor to water and climate tech startups and scale ups, and also consult on corporate water strategy and climate resilience. And also, I'm an advisor to KTM, along with our other three panelists. So I'm going to turn it over to them because they're going to provide the substantive aspects of this discussion. We'll probably feather in some questions here and there, but really looking forward to hearing from our experts. So without further ado, let me just do a quick introduction, and then my colleagues will go a little bit more deeply into their background. Dragan Savic is a global advisor with KWR Water and a seasoned expert in hydroinformatics, including artificial intelligence, data mining, and optimization techniques. Gigi Karmous-Edwards has 25 plus years of experience in digital technologies, which will benefit from her wisdom today and her experience in that space. She specializes in IoT, big data, and digital twin technology in the water sector. And Saša Tomić is an award-winning architect of leading hydraulic modeling software with over 30 years of experience in software development and data analytics. So great group. And I think I'm going to turn it over to Gigi first to kick us off with a exploration of AI and generative AI and how it's being deployed and what are some of the opportunities in the water sector. Gigi, do you want to go?
Sounds sounds good, Paul. Thank you so much for the introduction. As Paul mentioned, I'm an advisor for KTM, and I work with many water utilities on digital transformation. And of the last 2 years, kind of acting as an evangelist for generative AI in the water sector. I think generative AI has a lot of capabilities that we in the water sector actually require in order for us to continue our journey on digital transformation. But let's keep in mind that we're talking about generative AI and not generic AI, because as you know, AI has been around since the 1940s, the late 1940s, and it includes things like machine learning, which is a subset of AI, deep learning, which is a subset of machine learning that involves neural networks. But recently, what has been in the news is generative AI, which really forces us to think about new generation of content, because these large language models using natural language processing has really been trained on vast majority of data on the internet, textbooks, videos. And based on that large scan of data, they've been trained so that they can generate new content in the term of text and visuals like videos or images. And there's a whole lot of capabilities that come across with these large language models that we've all been hearing about in the news. And I'm really excited about looking at some case studies and examples of how water utilities and technology companies can start to leverage some of these capabilities.
That's great. Gigi, as you're talking, one of the things that I've been wondering about and read about is, is large too much at times, right? What about kind of large language models or narrowed language models that are more domain specific and almost verticalized? Is that something that you're seeing beginning to take root?
Yeah, I mean, some people have taken these existing, there's some open source large language models. There's also, access to closed source large language model that then can be used for further training to get it to work more in the domain specific regions. However, there is something called RAG, Retrieval Augmented Generation, which allows you to take some of these large language models and then use your own data for it to process through the query, question, and answer type of interactions with these large language models. So in a way, it's like a cheating. You kind of cheat your way to a verticalized large language model for your own use.
That's great. Saša and Dragan, do you have any questions you want to pose to Gigi at this point, or let him ruminate for a little bit?
Well, I would love to hear Gigi's opinions as where will AI take us in water industry and in short term and long term?
Yeah, I mean, I think Dragon, you and Sasha and I have had these discussions before. There's so many capabilities, but there's also a lot of hype, and I know that people fear some of these large language models. The fear mainly comes from data privacy because we are talking about critical infrastructure. And we're also, unfortunately, in a lot of water utilities, based on some surveys, some of the employees feel like, why should I work with generative AI? Because it could replace me in a job and I need my job. So I feel like those two areas we need to address, and we need to address with concrete ways of getting around it. First of all, I don't think it's going to take too many jobs because in the water sector, we're still looking to hire people. And we have we have our silver tsunami that we always talk about. So I don't think the replacement of jobs is really something in the water sector that we have to be prepared for in the next couple of years. And then from a cybersecurity perspective, I do think that you could use like a enterprise version of these large language models. You can download an LLM, an open source LLM, to your own servers in the cloud or on premise, and you could ensure that you don't have the threat for cybersecurity that way. But the capabilities are there. And I think we can start to utilize those capabilities, such as data analytics, computer vision, OCR, things like that, for the water sector. I'd love
Gigi,
to hear your opinion.
You reference hype, and I know that you and Dragan have a healthy discussion going on about the hype versus reality. So I couldn't help but turn to you, Dragan, and see if you want to weigh in and leaven some of the enthusiasm.
Yes, I first have to start with the disclaimer. Over 30 years, I've been doing AI and applications in the water sector, so I'm not opposed to it. What I'm worried about is that we are expecting too much too soon, and I've seen various technologies in the past that were like technologically way better than something else that we had. But because of that, or because of the approach we've taken, they haven't delivered as much as we were hoping. So I'm also worrying that this AI, call it hype, call it excitement about our capable technology, may actually cause the opposite effect. And Gigi referred to that by some people, kind of, why would I do it if I lose the job? But how about, for example, focusing on the areas where it can be directly applied? And I'm again in discussions with you guys and with Sasha, and we came up with few ideas. For example, the organization I work for, KWR, has over 10,000 reports over the last 40 years of the research done in the water sector. And I still need to find somebody who may be remembering that 23 years ago somebody has done this particular research, whereas AI can do that much better. So, Gigi, is there any way we can try and avoid that pitfall of advanced technologies not being accepted in the sector.
Yeah, I mean, I agree. There is definitely this, a lot of talk about it and a lot of fear about it. But I do think that if we can encourage people on a very small scale to start to experiment with these large language models and just start to see what works and what does not work. Very small capabilities like OCR capability, for example. We know a lot of water utilities still use pen and pencil in a lot of their data gathering. What if we start to use that OCR capability to translate that into an Excel spreadsheet, for example, or, you know, um, reduce the amount of data entry, which could come with a lot of errors from a human and probably less errors with OCR. So if we could just get them to experiment with this and also to validate the answers. If they prompt a large language model and they ask a question, make sure that the large language model also gives you, links to where those sources are so you can validate. And then trust will start building. It's not a matter of generative AI is going to start automating everything. It's more like, how can we use the capabilities very slowly and surely and validate it? And once it's validated itself several times, we can start to trust it and we can start to branch out to bigger projects. But I would say move slowly with the capabilities and understand what those capabilities are.
Dragan,
I don't know. What are your thoughts, Sasa?
Oh, I think I know correct answer to question is generative AI hype or reality? And the answer is yes, because it is both. uh, Recent research by Brookings Institute found that 30% of workers will have at least 50% of their job tasks disturbed. So the fact is that AI is not there to take your job, it's there to change your job. And if you are not willing to change it, you will end up same where maybe hand drafter is now. It's like how many drafting tables do we see in civil engineering companies? In 1980s, 80% of workers in a consulting company did drafting. Nobody does it anymore. Does that mean that they lost their jobs? I know. I think their jobs are much richer. With GIS and BIM, they can do much more and contribute much more to projects. It also doesn't mean that 80% of jobs were lost. It is that we became more than 5 times efficient. So the cost of doing consulting work went down, and a consulting company that had maybe 10 workers and did one project a year suddenly can do 5 projects, and instead of 5 they did 10 and hired 10 more people.
Dragan, your example of the 40,000 reports that you've accumulated at KWR over the years is, I think, a really great example of some of the potential here around knowledge management. And that is, I believe, largely a lazy asset, right? That research is largely not used. And I think we're beyond the efficacy of using literature reviews by a grad student to discern and distill knowledge, right? And so that seems like a really promising arena for generative AI, particularly if we can get to the trust that you talk about, Gigi, and avoid hallucinations, right? And have observations and distillations that are grounded in with links to where that information was derived from. So that seems like a really promising arena particularly for research institutions, but with utilities as well, given the sort of tacit knowledge that resides in utilities and the danger that can exist with it going out the door when someone retires. Saša, let's turn to you and talk a little bit about digital twins. And I think, these topics all are intertwined. So there certainly will be an opportunity to revisit and come back to the generative AI. But walk us through your perspectives on digital twins. And I know you argue that and assert that this is not a new technology, but perhaps you can talk about what is new and perhaps new deployments around digital twins.
So maybe it's worthwhile stepping back and discuss What do I mean when I say digital twin? Because it's somewhat open term, and you can use it any way you want. AWWA had a formal definition that Gigi and I had the opportunity to participate in. And AWWA at least defines a digital twin as integration of data and models to support decision making. So if we think of a digital twin of integration of data, models, and decision making, then we can step back and look at through the history of digital transformation and see where digital twins fit in. And when I talk about history of digital transformation, I'm really not talking about a utility or organization adopting digital transformation. I'm talking about history of humans delegating decision makings to computers. So there are three components. There is data, numbers, there are models, representation of the world, which basically kind of captures the state of whatever you're looking at and the behavior. And then there are some decisions to be made. If you are not making decisions, then the decision twin is not necessary. So how far back did we as a humans started making models and data of the world, since we invented the numbers? So we could say we started digital transformation when we invented numbers. That might sound a little bit unrealistic, but let's ask, when did we start using numbers in water industry? And people might say 20 years ago, 50 years ago. But the fact is, ancient Egyptians had Nile meters where they looked, and a Nile meter is just simple stairway going into a Nile. And they would look at which step of the Nile meter the Nile is to predict future flooding. So the model was still in human head, but the numbers were coming from outside world. So digital transformation in that sense might have started in ancient Egypt. If you want to take the model out of the human head and say, when was it where we measured some numbers outside and had models that were not in our head and made decision, you can go a couple hundred years ago. Dr. John Snow used information about cholera in London to plot it on the map to find out where the source of cholera. We didn't even know where cholera comes from. Why do I use this as an example of digital transformation in water industry? It's what he did next. He asked to close a water pump, which was the source of the cholera. How he could do that? Well, he was a physician to Queen Victoria, and he had the authority to close the water pump. But here we have a map that he plotted on. In his head, it would be hard for him to see all these locations and figure out where the cholera from. He used an outside model, a map with the numbers, information, location on the map where the cholera comes from to make a water decision. So you can say that this stage, and we are following the stages of digital transformation. You start with the ideas, then numbers, then information being a structured number that has a meaning that we can use in decision making. So the next step in this is you go from information to knowledge. And knowledge is when you start synthesizing different pieces of information to get more information out of it. So the knowledge stage, it's happened in 1980s, 1990s, where we had SCADA and we had GIS, and we suddenly started integrating to make these data sources to make decisions. And we at that point started passing some very rudimentary decisions to computers. If the tank is empty, turn on the pump. It's very simple, but if the tank is empty, it's information. It's not the data. It's not the number. This number has a meaning. It's that the tank is low and it's below some threshold, and the pump can be turned on. So we moved from data to information to knowledge. The next step is wisdom. And wisdom is when you can use the knowledge at the right time and synthesize it with your experience or models to make decisions which are aligned with some long-term goals. And we can argue computers are already doing that. Programmable logical controllers can check time of day, cost of power, and turn the pump on and off basing on wisdom that computers have. But the best example of the wisdom is GIS dashboards. GIS dashboards are synthesized information that allow humans still to make decisions, or SCADA dashboards. The next step in digital transformation comes the intelligence. And this is where I think we are. we can integrate data and models to make real-time models that can make predictions. So instead of making decisions based solely on the model, on the map, on some static information, or solely on the experience about system behavior, we integrate these two to move forward. So I think this is where digital twins come in and the intelligence portion of transformation. Of course, after this comes insight and then innovation. Insight is when we start seeing patterns in past behavior to develop new decisions. And this is where generative AI should lead us. These are the parts of generative AI that I would be advising to move slowly. But the generative AI might say, like, yes, your tank is low, and yes, it is a sunny day, so maybe there is a lot of irrigation, but the rate of it going down is very high. However, this is the first weekend of nice weather and it's Friday evening, so people are probably filling their swimming pools, so don't go out there and look for a leak in the system. And then this final innovation stage, we are not there yet. I can't tell you what that will be.
That was excellent, Saša. And one of the things that jumped out at me was your how you sort of broke up this almost this value chain of using data models and decision making. And something you said that I thought was really interesting that harkens back to what we were talking about earlier is, in some cases this is about delegating decision making to the integration of data and models, right? There may be somewhat routine tasks that really lend themselves quite well to automation and delegation. But there's other decisions that very much need to be retained and be human-centric, right? In terms of what a decision is made. It may need to have to do with making a choice around a long-term source of supply, right? There's a whole set of value issues and economics embedded in that. But it can be augmented, very much can be augmented by this integration of data and models. So I'm wondering if Gigi or Dragan, if you have any reactions to that from your perch and where you sit in terms of this delineation of, maybe what decisions might lend themselves to delegation particularly well in the water sector versus ones that should be kind of retained by people.
Okay. I think that we should keep the human in the loop for some of these decisions at the very beginning until, again, the things have been validated and they're very consistent. And then we can slowly move towards automation for some tasks. But you're right. I think, humans have to be part of this, part of the decision making most of the time, and especially long term, like you had just mentioned. So slowly but surely we'll move towards automation, but I think human in the loop is very critical at this stage. Dragan, what are your thoughts?
Well, first of all, I agree with Saša about digital twins not being completely new. What is new is that we are getting more and more this near real-time information to inform better models. So that's where the advantage is. If you're talking about digital twins and AI, I also think that we need to keep a human in the loop. I always like to kind of demonstrate it, but I like to have the red button to stop a process if something goes wrong. And that's how the operators in the water sector feel like. And what is AI good at? It's good at replacing us doing repetitive tasks, and we are not interested in doing those tasks. It's boring. So more time is left for us to doing something that is more creative, more important for operating the system. So I think that's where I see that marriage of AI and modeling. And final thought is, you're talking about decision making. I don't think machine will ever make those creative ones. it will allow us to be more creative, but lets machines automate and do what is repetitive and can be done much better and faster by the machine.
I do want to say one more thing to that, if that's okay, Paul. One of the areas where I think digital twins could be or generative AI to digital twins is today, as Saša and Dragan also talked about, you have these dashboards of information and knowledge that was gained from the models and the data. However, one of the most beautiful things about generative AI is these large language models is that they understand language. And not everyone is an expert and can look at a dashboard and understand how all of these variables interact with one another to get to the conclusion. But what we can start to see, I'm hoping to see this from a lot of digital technology companies, is that now a operator can ask a question that the large language model can take all the information from the dashboard and put it into an answer that's well understood by most humans. And what I think that brings to the table is democratization of information and knowledge, meaning that you don't have to be an expert in modeling. You don't have to be an expert in understanding these dashboards, but you can be curious enough to ask the right question. And hopefully, the accumulation of all that information will be dispensed in more friendly human language that most people can understand. So that's an area I'm super excited about. And then the last area that I'm really feel like is going to help with digital twins is unstructured data. So far, we've been talking about structured data, like SCADA data, sensor data, meter data. However, unstructured data is everything in between. And 80% of most enterprises is comprised of unstructured data. So videos, images, PDF files, all of that can now be included in the knowledge gathering of a digital twin. And you could even have things like notes from operators or field workers that can now be included in that insights or decision-making process. So those are the two areas I think is going to change digital twin in a very positive.
If I can just go back to your original question, Paul, because I think it summarizes all this. You asked, will computers make decisions? If we had this discussion, and I had similar discussions 2-3 years ago, most of people would say no. But did you notice how your question very quickly turned into, will computers make decisions with or without our supervision? The whole discussion was, oh, there has to be supervision. The second thing that Gigi brought up is, will computers understand us? It's one thing to make structured decisions like, given this data, you do this. It's completely another thing where somebody comes in and says like, oh my God, the pressure is dropping and the tank is emptying and I don't know what to do. 2 years ago, if you said this to any expert and say within 2 years, will computer understand and help you with this question? The answer would be resounding no. But today we know for a fact that computers can understand us. So these are these two big major changes that we will have computers making decisions and answering our questions with the supervision. Now that is very scary. But the way I reassure myself, I think, what is absolutely the scariest thing I do in my life? And I occasionally get in a large can and go in the air. We call that flying. And while I'm flying, we have a computer fly the plane. And it's better. It's like when I started flying, I would never fill my glass full because human would turn plane and spill wine on me. With autopilots, this never happens again. Like one was the recent when you had like large turbulence, but this is because autopilots collaborating with weather models. So we have computers make decisions about critical things about our lives, and we have pilots monitoring them. What is changing, what Gigi said, is that like we will be able to ask completely unstructured question and have computer help us.
Yeah. Such as, should I get the chicken or the pasta for the airplane meal, right? That's one of the questions that hopefully AI can help us answer. Dragan, that's actually a really nice lead into your topic, and also something that you referenced earlier about replacing redundant tasks, right? Which are not necessarily a really compelling and exciting body of work. Another area is dangerous ones, right? And so can you walk us through the role of robotics here and how it sort of can fit in to address and augment our ability to discern anomalies, problems in environments that are not well suited for people to be deployed into?
Yeah, that's that's absolutely true, Paul, because robots are widely used in other industries and industrial sectors. And in combination with the significant advancement of artificial intelligence and machine learning, um, that is contributing to the rapid growth of robotics and automation in those industries. And, those impacts are obviously visible in manufacturing, in logistics, in energy supply, and healthcare, most at the moment. So, and in all of those industries, they have a disruptive effect because they can actually change quite a lot in how those industries are delivering service to the population. So the idea, particularly of our underground infrastructure, and pipes are water pipes, wastewater pipes are usually buried in the ground and very difficult to access. um, how to assess the structural health of the infrastructure, how to assess what is happening in that underground as we speak, and how the water comes to our houses and it goes away. So, um, that transportation of water, the mapping, the condition assessment, um, looking into security, surveying, and mapping of pipe assets, that can all be drastically changed by robotics. And also, if we're talking about autonomous robots, automated robots that we do not have to control while they're underground, while they can map where they've been, they can see the structural condition of the pipes, report that, get recharged so they can continuously send that information. That's kind of the utopia um, of robotics in the water system. We have to be realistic and say, look, at the moment we have a small number of sensors in the system. They measure usually some kind of performance, secondary kind of performance of the system. So, what's the pressure? What's the flow? What's the level? Whereas to get into the health of that infrastructure and say it will last another 10 years or 20 years, we need much more information from various parts of those systems. So that's why there is quite a lot of research at the moment going on in these systems. And I have to say, for example, for the wastewater system, that's quite advanced because these are the ones that come on traction devices on wheels, and they can be easily tracked or tracked much easier than they're in the pressurized systems as the water distribution system pipes or transmission pipes are. But I can see that that is moving in the right direction, and that these robots are on the verge of kind of being that disruptive effect in the water sector, which we haven't seen for a long time, historically looking, maybe from the time when people started using simulation model. Before that, it was rules of thumb and engineers who managed the system, who understood how to kind of open the valves and control the pumps. Then with models, we've learned more and could convey that knowledge to early careers who haven't had the experience. And now through AI and through more information coming from inaccessible places in our systems, we can better plan for long term, because these systems have to last 100+ years. This is not like something that you buy to wear and then throw it away when it's past I don't know what is being kind of modern in the society, but they last for much longer. So we need to find ways to better understand what is happening in our underground.
Dragan, you noted, in effect, robotics are a good way to obtain data and information about inaccessible locations, right? Can you share your thoughts, and maybe Gigi and Saša, you come in as well, of where you see robotics and AI coming together? Uh, I would imagine that part of it is around image recognition, right? And some pattern recognition, but can you elaborate a little bit on that?
Well, the first application is, for example, to see the development or movement of sediment in these pipes, or particularly in the wastewater pipes, urban drainage pipes, and using onboard intelligence to predict when the blockage is going to happen and when to intervene, or intervene itself. If it has the ability to carry the tools. For example, we've heard of fatbergs, big blocks of fat and rags in sewers. They cost millions and millions of pounds, dollars, euros to rectify once they block the pipes. But imagine if something was already in the pipes, can deduce that the danger is there and go and intervene. That would be, for me, a perfect case for application of robotics.
Okay. I could also talk a little bit about computer vision. Right now in the medical industry, we read this report talking about looking at images of breast cancer, and that with computer vision, it was able to detect breast cancer 5 years prior to what a human doctor could see. And so imagine taking that capability on for, like you said, Dragan, the wastewater processing, for example. I wrote a GPT. I don't know if you're familiar with GPTs. It's a way OpenAI allows you to write these specialized bots for a very specialized purpose. I wrote one for taking sludge. You take a sample of the sludge during the treatment process, and you really look at the concentration of the different microorganisms and identify all the different microorganisms. Today, a human would take a slide and, basically go through about 10 points on that one slide to identify the microorganisms and then to try to calculate the concentration. This GPT, you upload the entire slide of the sample, let's say it's 4 drops, let's say it's a milliliter, and using computer vision, it can detect what microorganisms are in there and the concentration. And then based on that information, it can help give insights whether you need to increase your temperature, increase the aeration to further optimize your treatment. So here we're looking at using computer vision to gain insights in order to optimize the treatment plan. So there's different ways that we can start to use these capabilities from generative AI. And now imagine if you had a robot instead of a human taking a sample, a robot in the sludge constantly photographing what is around that camera robot type thing, and constantly getting that information and then constantly optimizing the treatment. So there you can go from computer vision and then some level of robotics, integrate them together and have a constant optimal water treatment plan process.
Gigi, this brings up something that I think cuts across all 3 topics, which is the centrality of data, right? And utilities, I used to work for a utility, and there's a lot of data. I think that's a technical term. But the curation and management and hygiene of that data is maybe what's often lacking. And it does seem, I'm curious what you all think about this, but it starting to approach data truly as an asset seems really critical here, right? Just the example you gave is one, would need to be generating images of sludge and retaining that so that you can train the robot to detect those types of things. So how do you all feel here about what we can do to improve the state of data, right? And in some cases, it may be gathering new data, but in a lot of cases, I think it's a matter of cataloging and tagging and cleaning up what we do have.
There are at least few things which we could do immediately. One is to get everybody within utility to understand the value of the data. And that's where generative AI will help, because people will be able to ask questions and get answers. So right now we have somebody in a field exercising a hydrant, and we are asking them to go to another hydrant and measure pressure, and they don't understand what's the value of this. But if we could have a chat GPT to explain that and help them do this much easier, maybe they would put more value on the data. Plus, they will be able to go to a hydrant and say, what pressure should I expect at this hydrant? And the system will tell them and make their job easier. The second part is to understand how to structure, organize, secure your data. Right now, a lot of utilities, rightfully so, are very worried about their data. So they're concerned about putting their data on a cloud. They're concerned about third parties accessing their data. And that same guy will take their credit card and go to a street vendor and give it to them, giving them all the information about their money, which is on a cloud. So we need to make these parallels to other industries. Banking data is all on a cloud and secure enough. So we can have water data all on a cloud and secure enough, and we can allow everybody the right level of access, same as the street vendor can charge a card but cannot transfer money out of your account. Operator in the field should have the right level of access for data where it's useful for her or him, but maybe not be able to change wrong data. So that's the education that should be happening right now.
Yeah, so I think it could help in a lot of ways. There's two areas when usually I talk with water utilities that serve as challenges for digital transformation. One is, yeah, we do collect data, we have it, but it's dirty data, it's unreliable, so we cannot use it. And then the second area is, yeah, we have data in different systems, but the systems are siloed, and we need to integrate these, and especially a digital twin requires the integration of these siloed systems. So with the first one, data analytics is part of these large language models, and it's not subject to hallucination because they would, these large language models like OpenAI, for example, we use these Python packages like pandas to run different algorithms in order to cleanse the data. The same algorithms that most of these digital technology companies will also use to cleanse the data. But now the capability is there on pennies on the dollar. So I would say for most utilities, whatever data they do already collect and have, and especially historical data, keep it as long as possible because that is extremely valuable, as Saša and Dragan both talked about. So yeah, keep the data and then cleanse the data. And now you have cleansed data, you can start to utilize it in different forms of data analytics in combination with unstructured data. The second area that I am super excited about for generative AI is this about 30 years ago when we first started building these systems like SCADA system and CMMS system in the water utility space, we never really started thinking about standardization, and especially of assets. Right now, every utility labels assets their own individual way. But these assets are the same, regardless of which utility you are, or which part of the world you're in. There is an opportunity, I believe, for standardization now for these asset data and asset metadata. And if we can start to agree upon this, you can start sharing data across utilities and then really using large, massive amounts of similar data sets, consistent data sets to train some of these LLMs to help in the water sector. So I do think that generative AI can help map whatever a utility, however a utility has labeled its assets to some standard. And we've seen work with British Water and WASA in Australia collaborate together on BIM and coming up with a uniclass classification. And this is extremely helpful if many utilities start mapping their own data sets to the uniclass classification. So we can start to standardize things. And once things are standard, these different siloed systems will have the same consistent way of naming and localizing these assets so that the data integration will be a much simpler task. So they're the two areas I think.
Yeah. Big opportunity for the sector to come together, right? To collectively work on realizing the potential here. Dragan, you got the closing responsibility, at least for this answer. So 2 minutes.
Thank
What do
you.
you think?
Thank you, Paul. And Gigi and Saša have touched upon most of these things. I would just say a couple of things. One is that the water industry people usually say, but the quality of our data is not good for this AI. We cannot do the modeling because it's not good quality. But I go back to Sasha's point. You have to make decisions now. So the best that you can do is use your best data to do that. So that's the first point. There is no reason of waiting to collect some more data. The other thing is interoperability, because we have lots of data, as Gigi just mentioned, and we need the ways of integrating them somehow, and metadata, the description of the data about the data, description of what's in the data, what's the time step, how long is the time horizon, and everything else has to be part of it, so that we can use the data, and using then AI to kind of correct some of the errors, fill in some of the missing data, finding outliers, and making the best possible decision based on what we have at the moment. And then that will help us identify what else we need to collect in the future. So for me, those are the key ones. Obviously, there are so many other issues with data and how we use it, but I'll leave it at that. Thank you.
Well, that's terrific. And, perhaps one of the takeaways here is, obviously asset management is a huge issue for utilities. And perhaps part of this is making data a central part of asset management, that it's an asset in and of itself that merits the same sort of scrutiny and attention that pumps and pipes get as part of asset management. Well, this has been a really terrific discussion. I know there are 3 or 4 or 5 paths that I wanted to go down with each of you, but we couldn't because of time. So next time, perhaps we can have like a 4 or 5 hour webinar and subject everyone to your brilliance. But this has been terrific. I hope everyone has a chance to listen to the entirety of this webinar and follow up with any questions you may have to KTM. Wanted to thank Gigi, Saša, and Dragan for this, for spending your time today and walking us through. And that's a wrap. Thank you, everyone.